Okay, before start talking about practical aspects of databases, we will need to make an overview on the database that we are going to use. Obviously, in order to understand this overview, you must have already studied the theoretical part, otherwise most of the concept will be absolutely incomprehensible to you. Okay, the database that we are going to use in the next practical lessons is the Northwind database. The database designed by Microsoft of an import-export company, so companies which buys from suppliers and sells things to customers. This company buys and sells food. The database is oversimplified with respect to one of a real company, obviously, but it's enough to show all the details and all the problems that you may step into. Okay, let's start looking at this database. Whenever you start designing a database and whenever you start looking at a database designed by somebody else, usually the best choice is starting from the external tables, the one which are less involved into the relation schema. So we start on the left with suppliers table here. Let's zoom. Okay, suppliers tables contains the details of supplying companies. Companies are identified not but by the value-added tax number, as it will be probably better, but by a supplier ID. Company name, all the possible fields of a typical company. You can see that suppliers is in relation one-to-many with products. This has a severe impact on the database. It means that each supplier can supply several products, but each product has only one supplier. Okay, if you want to get mozzarella from another supplier, we cannot, because each product has only one supplier. This is a database restriction. In real life, this is not what happens. So in case you design things like this in your database, obviously please justify it, specifying that it's an oversimplification. So you can see supplier is connected to products. Each product has one and only one supplier, but each supplier can supply several products. Let's look at the products field. Okay, these are obviously the standard products field for a product name, unit price. Units in stock means how many products of that type do we have in our storage. Units on order, how many products are on order, so we are waiting them from the supplier. Reorder level, when units in stock goes below reorder level, we have to reorder. Quantity per unit, well, since this is food, products, the unit product is not always the same. For example, for eggs, you have 6 eggs in a box. For milk, you have a liter of milk, and for other food, you have different units. So quantity per unit specifies this. For example, 6 eggs per box or things like that. In products, there is a field called discontinued. We have already talked about this kind of field. Since sooner or later a product will go off production, so the supplier will not produce it anymore, and so we'll have to stop selling it. We cannot, however, delete a product, because if we delete a product, all the people who have ordered it in the past will have their old orders with orphans records. So this is the famous problem of orphans record that we discussed during the theoretical part. So in order to delete a product, but not really eliminate the record from the database designer has introduced this discontinued field. If it is set to yes, it means that that product exists in the database only for compatibility with the past orders, but is not really produced anymore. If the field is set to no, that product is in production regularly. You can see also there is a relation with categories table. Okay? Relation is one to many, so each category contains several products, obviously, and each product belongs to one category only. This category table is, as you can see from its field, totally useless. It contains the category ID, the category name, a description. A category name are things like vegetables, beverages, dairy products, meat, a description, which is completely useless. Everybody knows what vegetables are, and a picture, so the picture of some vegetables, also completely useless. So most of the fields are completely useless. The only meaningful field is category name. So you can ask, why is it really necessary to have a table? And I answer, no, it's not necessary to have a categories table. Category name can be set here as a field, and that's all. You don't need the table. The designer has decided to put the table for one very specific reason. Because if you put category name here, then everybody who tries, all the people who tries to insert a new product will decide the category by themselves. One will write vegetable singular, another one will write vegetables plural, another one will abbreviate with veg, another one with veget, and at the end you will find a field which is useless because the same thing, vegetables, is written in 300 different ways. If you want to force the person to write exactly what you have decided as category name, one of the typical tricks is the following: building a separate table with the fields that you will want to appear exactly, written exactly as you want, and connect it via a one-to-many relation. In this way, the person who will insert a new field here in products table could not write the field himself, but will have to choose one of the fields which belongs here to categories table. And so you will have all the vegetables written in the same way as category ID of vegetables. Okay, so this is the typical trick to force a field to belong to a mandatory list of values and not leave the user free to type whatever he wants inside. Let's jump on the other side. Here you have customers. This is a business-to-business activity, so customers are probably restaurants or resellers. So these are companies. You can see here the same fields as the supplier practically because they are companies. Okay. Customer is related one-to-many with orders. It means that a customer can place several orders, obviously, but an order belongs to a single customer. So there are not joint orders made by two customers together, as in 99% of this kind of database. So most databases never have joint orders. So each order belongs to one customer only. Okay. Moreover, you can see here ship via. Each order has only one shipper. Shippers are shipping companies like FedEx, TNT, or the Italian Bartolini, DHL. So each order is delivered to the customer using a single shipping company indicated here. Okay, here there are all the administrative details of the order. Well, apart from the order number, who is the customer, linked here, when the order was placed, when the order is acquired, when the order was effectively shipped, how much does the shipping cost, to whom is the order shipped. There is also a relation with table employees. Table employees contains the list of the employees of the company. You can see the typical people list: first name, last name, title, birthday, hire date. There's also the picture, the photo here. The relation is one-to-many, meaning that one employee handles obviously many orders, but each order is handled only by one employee. So in case of problems, we always know whom to blame. So each order has only one employee as responsible. Okay, let's go on. You can see here in employees, there is a particular field, reports to. Okay. This is a field which indicates who is the boss of each employee. Uh, I did not draw the relation, but in theory, there is a relation starting from reports to and going back to employee ID. So it's a very strange case. There is a relation which goes to the table itself because each employee reports to another employee who is his boss. So there is a relation here in theory starting from reports to and going back to employee ID. Okay, a many to one relation. Okay. Each employee reports to one employee only. Okay? And each employee is reported from many employees. Obviously, there is one employee, the president of the company, who reports to himself. Okay, so here reports to can also be your ID. So you can also report to yourself if you, in case you have no boss at all. Okay, I didn't draw it because it's a very particular case. Okay, it's a case used when building hierarchical structures. Okay, let's go here to other details. We have already discussed this thing here in the theory. Since the relation between products and orders must be many to many, because inside an order you must be able to fit several products. Putting the restriction that inside orders there is only one product, it's not feasible in most of the buying and selling companies. Here we must put a junction table between products and orders. This junction table simply tells you which product is inserted in which order and in which quantity. So for example, this order contains 20 apples and 3 watermelons. So you will see here the order ID, the product ID of apples with quantity 20, then again another record with the order ID, the product ID of watermelons with quantity 3. Okay. There is also a discount, so this database gives you the possibility to apply a discount product by product, order by order. So each order you can apply individual discount. So discount, since discount is set here in this table here, it means that you can apply discounts very specifically to each individual product belonging to each individual order. Okay. There is, however, unfortunately, this unit price, which is here and here. Well, if you do something like this in the exam, I will consider it a severe mistake. Okay, you have a field which is in two tables, and I don't know which one is the official one. Okay, here I can argue that probably the designer wants to set this as official product price, and this as the price which is really applied to the order. This, however, it's not a good excuse because there is also field discount. So if he wants to apply a lower price, he can just set a discount. Okay. So honestly, at things like this, I will consider it wrong. So you either put unit price here, meaning that the price is fixed, and in case you want to change it, you can only apply discounts. Okay. Or you do not put unit price here, you put unit price only here, meaning that you have a specific price for each product inside each order. So the price is completely variable depending on the product, on the order, on the time, on the customer, on everything. Okay, so this is the typical details table that we have discussed already during the theory. Okay, so this is the overview on the database. And let's go to opening it. I have here, where is my access folder? Okay, it's Northwind 2003.accdb. Okay, ACCDB is the new database extension, MDB is the old one. We use Northwind 2003 because Northwind 2007 and Northwind 2010 and 2013 have become really too complicated for this course. Okay. Whenever you open the database, you will hear a security warning. Don't worry, you can enable content. Then the splash screen. Well, you can flag here, don't show the screen again, and it will not bother you again. I cannot because every year I have to show it. And if the computer lets you, you can, no, it is completely locked. Okay, finally. And now you can enter the database itself. Okay, let's see, however, before some little information on Access. We are going to use Access 2013. It's identical to Access 2010, and apart from a little variation on the menus, it's identical to Access 2007. The graphical interface of Access is not so important as it is for Word and Excel. because the important thing for Access is the core, the structure, what you build inside the structure of your databases. The graphical thing looks always more or less the same. It's part of the Microsoft Office package. It is not part of all the version of all the editions of the package. Some editions don't have it, for example, the student edition. It lets you administer the relational database, update the database through forms, build complex queries, and create reports. Queries will be the most important thing. Forms and reports you will see are just two extra things. It is not the most used database. It has very strong competitors. While honestly, for Word and Excel, competitors are very small. Access has very strong competitors, most of all Oracle. Oracle is a famous big database, and also MySQL. MySQL is the database used for websites. So on the web, most of the web sites use MySQL. It's a free and open source database. Okay, we have already gone through Northwind 2003 database. Okay, I suggest you to copy the file on your desktop, press enable. The first thing you have to learn on databases, in particular Access also, is that it saves automatically your data modifications without asking you anything. So while for all the other Office products, you have to explicitly press save to save your file, Access doesn't. If you do any data modification, so any modification to your data, everything is saved automatically without you pressing anything. Okay, and undo is possible only for the last action. This is the database philosophy. Database philosophy is completely different from word philosophy because most databases are designed for a collaborative work, so a work of several people together, and whenever you do something, it must be immediately available to other people, otherwise other people will change what you're doing and chaos will happen. So whenever you do something, it's immediately saved by Access. Let's see. Okay, so I will just show you an example in case you don't believe me. I open table employees. Okay, I change Davoglio Fuller Andrew to Fuller Andrew. Okay, I just put the mouse somewhere else. I don't click on save, I don't do anything, I just close with the X here. Okay. Now I go back to my desktop. I reopen the file. I press OK. Employee. Can you see Henry? Okay, let's re-put the W. So any data modification is immediately done. Instead, if you do a structural modification, so you change the structure of a table, the structure of something, you will need to explicitly press save here. So the save button here is useful, but only to save the changes to structures. If you make a change to data, you don't need to press it, and you don't have to press it. Access will do everything. Okay. So file save simply saves objects inside the database file. So it's not like the word save, which saves the file on your disk. The file on your disk is saved every time automatically. The save simply saves the objects that you have inside. So Access is a container of objects, for example, tables. So if you do any structural modification to a table, for example, adding a field, then you will have to press that button save to this button save here to save the modification to the structural modification to the table. But if you do a modification to data, you don't need to do it. Okay? In case you want to duplicate the database, so use the save as that is present in Word and Excel. Save as, save database as. So you can see that the save as has two options. Save database as saves the entire database in another place. Okay. It's the save as that you have in Word and Excel. Save object as instead is the other save, this one. We simply save your table with another name inside the same database. So you have to look at the Access file as a container of other objects. So it contains tables, it contains other things that you find here. Okay. Okay. let's see each table. Okay, we have already opened this table. Let's reopen it just to show you. You can double click on a table, simply opens it. In case you don't see the object in this way, here from this menu, object type and all access object. All access object lets you see at all the objects, and object type organizes your object by type. Okay, so I double click here. This is the datasheet view. So I am looking at my table in datasheet view. You can see datasheet view, it's more or less like Excel. So I'm looking at the column and the rows like Excel. Okay. There are some differences, for example, the presence of this little plus, but most of them is like Excel. You can also change the fields as if it were Excel. Okay. The other one, you when access will release, the other one is this one, which is the design view. Okay. In the design view, you look instead at the structure of the table. Okay, you can see here which field we have, the field type, some extra information on the field. Okay, so these are not, you don't see the content anymore, you see the structure of the table. Okay, let's see. And let's go through the field types. You can see the field types here. Okay. For example, last name is show text, birthday, date, time, etc., etc. The name of the field type has slightly changed from Access 2010 to Access 2013. Well, don't worry. At exam, you can use both. To me, I understand also the Access 2010 old names. Okay, let's see if in the slide I have the new names. Yes, I have the new names. So the field types can be show text. This means that your field contains text up to 255 alphanumeric characters. So it's good for names. It's not good for an entire essay. Okay. Long text, maximum 65,000 characters. So good also for not very long, honestly, text. Okay, 65,000 characters. So text long, but not too long. Number, currency, and auto numbers. So number is numbers, every number. Currency is basically the same thing as number. From the computer point of view, it's identical. But the difference is that currency has also the currency symbol. Okay. Auto number. Auto number is simply a number, but which is automatically incremented by 1 whenever you insert a new record. It's the typical choice for ID. Do you remember the ID? The ID was a number which is a consecutive number, so incremented by 1 whenever you insert a new record. So if you set a field to auto number, it will be a number, but every time you insert a new record, Access will, for you, select a number which is one more than the last one. Okay. So in fact, you find here that employee ID is auto number assigned automatically to a new employee. So Access, whenever you insert a new employee, will increment this number by 1. It's a typical field for ID. Okay. Then we have date and time. So for Access, like for Excel, date and time are together. You cannot split them. You cannot have time or date. Date and time go together. Yes, no field. It's a field which simply contains two values. Yes, no. Yes means true or yes. No means false or no. Okay. All object. In case you want to insert external object, for example, pictures, videos, audio, but also documents, other PDF. So for example, if you want to insert a curriculum in PDF for your employees, you can insert it. You can decide to link the object. It means that the object stays outside the database, or to embed it. It means that the object goes inside the database. If you choose to embed it, obviously your database will be very large. So because if you embed a lot of videos inside your database, it means that the videos are copied inside the database, and the database will start to be very large. Hyperlinks, well, hyperlinks are hyperlinks. Everything on which you can click, email addresses, web pages, things like that. Okay, let's see if I've forgotten other things. No. Long text, number, date, currency, auto number, yes, okay. Well, we avoid the other fields, the non-important fields, and we'll see lookup wizard later on. Okay, you can see that each field has further here informations. We'll deal with them later. Oops, I accidentally, okay. Now, please don't save, otherwise you will save any structural modification you have done to your table. Okay, simply close the table. Okay. A very important information on number. Okay. Can you see here, numerical codes are text and not number. There are, in real life, there are several situations in which you have a number which looks like a number, but it's not a number. What do I mean? For example, your telephone number. Your telephone number is composed of digits, and thus is called telephone number. But does it have any mathematical information inside? Are you ever going to take your telephone number and subtract 20? Or take your telephone number and divide it by 2? Or apply a square root to your telephone number? No, all these mathematical operations are completely meaningless. You will never take a telephone number and subtract it from another telephone number, getting the difference of the two telephone number. No, it's meaningless. So whenever applying mathematical information is meaningless, even though the telephone number looks like a number, it's not a number, it's short text. So please, when designing a database, if you have telephone numbers or any numerical code, it's not a number, it's short text. Why? Because if you choose short text, you will have the possibility to insert spaces, slashes, dashes, letters in case they have. Other examples are the house number of your address. Most house number contains only numbers, but some of them contains letters or slashes or strange symbols. Okay. Also, the telephone number contains the plus, sometimes spaces. Another example is the barcode. The barcode of a product, even though it's composed of digits, for example, you have several barcodes starting with 0. Okay, a number cannot start with 0, so it's just short text. It's even though it's composed only of digits, it's short text. It's not a number. Number are only things which carry on a mathematical meaning inside. For example, a year can be a number, even though you are never going to apply a square root to a year, but probably you're going to subtract a year from another one and get the difference in years, or you're going to add one to a year and get the next year. So it makes sense making some mathematical operation to years, and thus years are numbers. Okay. They are not dates. Dates must have also the day and the month. Okay, years alone are numbers. Another example which comes out very often is the zip code or the VAT or the value added tax number. Zip code are not numbers. Okay, zip code are short text. For example, because several zip codes start with 0, or in some countries zip codes have letters inside. Okay, so pay special attention to this thing here when designing a database, if you have to design it, because it's considered to be a mistake, obviously. Okay, let's see here, if we have things like this. Can you see postal code is short text and home phone is short text? It's not number. Okay. Oh, we have primary key. Oops. Can I switch to access? No, I can't. Okay. The primary key is indicated by this little key here. Okay. You can set it simply clicking here. If you unclick, you will remove the primary key, which is never a good idea. You can't change because it's involved in some relationship, and so Access doesn't let me change the primary key. But I can change the primary key somewhere else. For example, auto details. I think I can remove the primary key. Okay. Okay, and you can set a new primary key just clicking here. Okay. As you have seen before, Access allows you to have a multi-field primary key. In theory, this is allowed, but please don't do it. If you really need a primary key here, can I go the details ed So if you are designing this database, please don't put this kind of multiple field primary key, but most simply like this. Okay. So setting a primary key is very easy. You decide the field and you click on primary key. If you build a table, a new one, and you don't set the primary key, Access will kindly ask you whether you want to set the primary key automatically, whether you want an ID field to appear automatically. You can answer yes, and he will build the ID field for you. Okay. Now, can you see, I have done structural modification. I have changed the primary key, a big structural modification to this table. If I try to close it, Access will warn me that I need to save it if I want to confirm this modification. This is what I explained before. Any structural modification must be explicitly saved. If you instead do data modification, they are saved automatically. Now, I don't plan to change here the primary key, so I just answer no. Okay. I close also this one. Okay. And let's go to the core of this database. We'll take up with tables again at the end of the data access part. Let's go into the core with select queries. Queries is the most important thing in a database. You basically build a database to store your data and to make queries. What is a query? A query is a question that you ask to your database. It may be as simple as who are my customers, or it may be much more complex, such as tell me the average quantity ordered by customers from Finland in April 1992. Okay. Every time you ask this kind of question to your database, the answer is always a table. So database cannot answer in any other way. The database will answer producing a virtual table. So you ask something and the database will produce a virtual table. It means it's a table which exists only as long as the query is open. If you close the query, the virtual table will disappear. This virtual table is called view. So the database will produce this view temporarily, show it to you, and will disappear whenever you close the query. It's an advantage that it disappears because it means that when you will reopen the query, the table will be recreated. So if in the meantime you have changed the data, the table re-updates itself. So the table, the view, the answer to your query is always perfectly up to date. Okay. Let's try to do some queries immediately so you get to know immediately the meaning. So where can you build queries? With create, okay, query wizard. You can use query design if you are rather expert. It's honestly faster. I do use query design, but since you are not expert, we'll start with query wizard. You have here already many queries already built. These are rather complex. These are example queries. Okay, but we will build new one by yourself. So you start with query wizard. Okay, first of all, I will just simply want a query which lists the products. Query wizard. Always choose simple query wizard for the moment. Okay, so I will want a query which lists my products. So I from table products. Okay, I will want product name. Well, if you want other information, let's choose also quantity per unit and unit price, just to add some information. So you can select the fields that you want. Next. Always leave details. We will learn later on to build summary queries, but we will not use this tool here. Next. Give to your query a name. So query 1, for example. Finish. Test the answer. So you can see it's a table. It looks like the products table, okay, but it's not the product table. Okay. So it's a virtual table. It's a table which exists only for the moment. It will disappear as soon as you close the query, and it lists all the products. Okay. Pay attention, however, that even though it's a virtual table, if you do any modification to it, Access is so intelligent that he guesses that you want to make the modification on the original table and will immediately replicate the modification to the original table. So never do modification to your views unless you really want to do modification to the original table, because if you do any modification to your view, Access will replicate it to the original table. Not always. It depends. If your query is very simple like this one, he will do. If your query is extremely complicated, he will probably not know what to do, and so he won't do anything. Okay, but pay attention. Don't do modification to your queries result, unless you really want to modify the original table. So you can see here there is the complete list of the products that we have. You can see here there are 77. Okay, 77 records. Okay, now I go here to home. Remember to go to home, otherwise you don't find it, because many of you try to find the thing that we're looking for now here, but you have to go to home and click on design view. Clicking on design view will switch from datasheet view to design view of the query. So also queries have a datasheet view and a design view. The datasheet view is the answer that you want. The design view instead gives you what you are asking for. In this case, you can see I am asking from table products, I am asking for the product name, the quantity per unit, and the unit price. Very simple. If you want to remove a field, just select it and choose cut. If you want to put the field back again, just drag and drop it from here. Okay, very simple. Okay, you have the opportunity to sort things. Suppose I want to see my product, but sorted by price, so I choose sort ascending. Okay. Unfortunately, if you want to have, for example, your product sorted by price, in case they have the same price sorted by name, you cannot do like this. Okay. Because if you do like this, they will be sorted by name and then by price. Okay. So you have to put name after price. Well, now, just as an example, let's leave sorted by price, and that's all. Okay. So unfortunately, this little interface is very user-friendly, but not when you have to sort by things on the right and then by columns on the left, because the sorting is performed always from left to right here. So let's sort by unit price. You can click on run, or you can click on datasheet view. It's the same. Okay, you can see now the products are sorted by unit price, ascending, which is the most expensive one. Côté de Blaye, the cheapest one, Gay Toast. Okay, now let's go back to design view. You can see design view, you can do a lot of modifications. Let's remove this sorting and sort them by product name. Okay, and suppose that now I ask you to choose only the products which have a price larger than 20. So you can put criteria, you can see it already here, criteria, larger than 20. Criteria is put in this strange way, so you don't put the left side. The left side is implicitly unit price. So this means unit price larger than 20. Even though it's a currency field, please don't put a currency symbol. As I told you several times, currency and number in practice for a computer are the same thing. The only difference is that currency displays you the currency symbol. Don't put the currency symbol, it will confuse him. So I just now click run, and can you see all the products whose price is below 20 have disappeared. Why my computer is so terribly slow? I click here and nothing happens. Okay. Okay, let's switch back to design view. Okay. Let's make other. Suppose I want prices larger than 20 but smaller than 40. Okay, how will you put larger than 20 and smaller than 40? Okay. You have several options. The strangest one is to put unit price again here and apply smaller than 40. Okay. This will work. You will see two unit prices, however. Okay. If seeing two unit prices disturbs you, just click uncheck show here. this field will still exist, so will still be taken into consideration, but will not be displayed. However, it is honestly not the best choice. There are better choices. One of them is writing larger than 20 and smaller than 40. Seems strange, but it is an instruction that Access is able to understand, even though it's written in a strange way. So you can put and or, and also the parentheses, and also not here in the criteria, and Access will do its best to understand. Whenever you put a criteria, it's always a good idea to click on Run and check carefully that it works. Okay, it works. But if your criteria is like this, it's even better writing between 20 and 40. Okay? So you can use also between operator, between 20 and 40, and this will let you can see same thing. So whenever your condition is between something and something else, using between it's much better. If you, for example, don't want to show the unit price, but still apply the condition, just uncheck show, and you can see unit price is still taken into consideration, but it's simply not displayed. So this not show, it's very useful, because usually when you don't want a field, you just cut it. But sometimes you don't want to see a field, but you need it because you have a criteria, or because you have a sorting criteria, or because you have something else you will see. And in this case, the show it's useful. And now I have a task for you. Let me restore back, if my computer lets me do it. Okay. Sort your products first by unit price and then by product name, without moving the product name on the right. So I want to see my product sorted by first by unit price, and in case two products have the same price, by product name. But I don't want to see product name on the right. I still want to see product name on the left. Okay, you can stop the video and try to do it alone. Okay, now let's do it together. Well, if you choose it like this, obviously, it will not sort by unit price and then by product name, but first by product name and then by unit price. You can check yourself. Okay. So in order to do it, you have to apply this dirty trick. Take product name, put it here, sort here, not sort here, and not display it. So in this way, you will sort by unit price, then by product name. This second product name will not appear as it is not flagged. And you can see first by unit price. In case two things have the same unit price, like these two, by product name. Okay, but you don't see the other product name, which is the one doing the sorting. Okay, it's a little dirty trick to adjust the sorting problem of Access. Okay, we stop here for the first video. If I can. Seems I can't.